Welcome to the Simplex Method. In this lesson, we will learn how to solve maximization problems step by step using a special Tableau. Think of Simplex as a recursive algorithm that leads to the best solution. We start with a real application. A juice company wants to decide how much of each drink to make, based on available ingredients and profit. This is the kind of question linear programming was born to answer. Here we define the decision variables and write the objective function and constraints. The goal is to translate the word problem into math. Once the model is built, the Simplex method can take over and do the heavy lifting. This slide explains standard form. In this section, we only work with maximization problems where all constraints are less than or equal to and all variables are non-negative. In other words, we study the most basic form for now. Slack variables are added to turn inequalities into equations. They measure unused resources, like leftover juice or unused time. They do not represent products we sell. They just help the system fit neatly into Tableau form. This is the initial Simplex Tableau. At the start, the slack variables are the basic variables, and the decision variables are 0. That gives us the initial basic feasible solution. It is usually a boring solution, but it gives us a legal starting point. This slide gives the logic of the Simplex algorithm. We choose an entering variable to improve profit, a departing variable to keep the solution feasible, and then pivot. We repeat until the bottom row has no negative entries. That means the profit cannot be improved anymore. Now we do the first pivot. Since -60 is the most negative entry in the bottom row, x1 enters. Then we use the ratio test to decide which basic variable leaves. After pivoting, we get a better feasible solution and a higher profit. We are not done yet because the bottom row still has a negative entry. So we do another pivot. This time x2 enters, s1 leaves, and the new Tableau turns out to be final. Now we read the answer directly from the final Tableau. The company should produce 1,800 liters of drink 1 and 600 liters of drink 2. The maximum profit is $1,380. So the math has officially chosen the menu. This slide summarizes the Simplex method as a sequence of steps. Add slack variables, build the Tableau, check the bottom row, choose entering and departing variables, pivot, and repeat. If you remember that cycle, you know the method. These are the key terms you should know well. They are the vocabulary of the Simplex method, and they come up again and again in examples and exams. If these words make sense, the whole method feels much less scary. Now we move to a three-variable application. A manufacturer makes three types of plastic fixtures and wants to maximize profit under time limits for molding, trimming, and packaging. This is where Simplex really shines, because graphing three variables is not fun. Here we define x1, x2, and x3 and build the linear programming model. The objective is profit, and the constraints come from the available process times. Once again, the main skill is turning a real situation into equations. This slide shows the initial Tableau and the initial basic feasible solution for the three-variable model. Just like before, the slack variables start in the basis and the decision variables start at 0. The profit starts at 0 too, which is mathematically valid but financially depressing. Now we perform the first pivot for the three-variable example. The most negative bottom row entry tells us that x2 should enter. The ratio test shows that s1 must leave. After pivoting, we get a new feasible solution with a much better profit. In this Tableau, there is a tie for the most negative bottom row entry. That means we can choose either x1 or x3 to enter. Here we choose x1. Then the ratio test tells us that s3 leaves. Ties in Simplex are allowed, so the method is strict, but not rude. This is the final pivot. x3 enters, s2 leaves, and the new Tableau has no negative entries in the bottom row. That means we have reached the optimal solution. From the Tableau, we read the best production plan and the maximum profit. Here is the big picture. The Simplex method improves a feasible solution one pivot at a time until no more improvement is possible. So the main idea is simple. Organize the data, pivot carefully, and keep going until the math tells you to stop.